Good evening, guys. Sorry, my previous class got delayed due to some technical glitches. Okay, am I audible?
Yes, sir.
Yeah, we'll get started. So what was the last topic we saw? We were doing some problems, right, from the textbook. Can someone tell me what was the last topic we were saying? Can somebody respond, please?
Sir, I think we did the last problem as 4.21 from textbook.
4.21. Okay. Okay. So I think there is only one, there are two subtopics that are left out. Right? So what are the two subtopics? That is relative velocity in 2-dimension and uniform circular motion. Okay. So by the way, did you guys see what is there for your term 1? Did you guys see the syllabus? I hope your school would have informed you already, right? So you guys also have, right, 2 terms. The exams are broken into 2 parts. Yes or no?
Yes,
Do you guys?
Yes,
Yeah,
sir.
did they inform you about the syllabus and all those things? What are the chapters you have, the first term and the second term?
no, sir, they didn't discuss with in school, but then they
But
sent the PDF.
okay, that's fine. But you know that, right? That's enough. I just wanted to
Sir,
find out.
can you
Anyways,
please tell it, sir?
Sir,
Sir,
till
I have not.
gratification.
No, I will not have it now. I will hold a separate session for it.
Okay.
I'll hold a separate
Okay, sir.
session, but I just wanted to find out whether you guys know this update or not. That's it. Okay, so shall we get started for today's class? Let's see. So write down the heading as relative velocity. So this we have already seen.
So are
Right?
you presenting your screen?
1 minute. No. Are you able to see now?
Yes, sir.
See, now the question is relative velocity. Right. Now you guys tell me, you have already seen this word, right? Where did you see? In the previous chapter itself we saw. Then again, why are we discussing it now? So what is the difference between the relative velocity that we discussed in the previous chapter and this one? So before that, can you guys tell me what do you mean by relative velocity? If relative velocity of first object with respect to second is what actually? It is the velocity of the
V1
first
minus
object.
V2.
V1 minus V2. There is a small correction that I need to do. Can someone correct it? Formally, everything is right. But you need to ensure you write it in the vector form. Because I use the word velocity, I didn't use the word speed. Right? So relative velocity basically means V12 vector is equal to V1 vector minus V2 vector, or velocity of second with respect to one is V2 vector minus V1 vector. Right? If this is going to be the scenario, then this we have already applied for a one-dimensional motion. Now the question is, how are we going to apply the same thing for a two-dimensional motion? Right? And the answer to this is very simple. Again, you can either apply it in the form of a standard vector, that is in the form of I cap, j cap, or k cap, or you can use the concept of resolution of vectors. So I hope you guys remember what does resolution of vectors mean, right? So that is what we are going to see in this context. In today's class, we are going to concentrate only on relative velocity. In tomorrow's class, we will see uniform circular motion. With that, the chapter will be over. So if I'm clear till this point, I will get started with direct examples. So you guys let me know. Am I clear till this point? Guys, yes or no? Why is the response level going down in each and every class? Reason. See, there is a question like this. Rain is falling vertically with a speed of 35 meters per second. Okay. And there is some wind blowing after some time with a speed of 12 meters per second in the east to west direction. Okay. In which direction should a boy waiting at a bus stop hold his umbrella? Okay, I have something to ask. See, I'm using a different software, not sure of how to take the screenshot and all. Okay. Is it okay if I write on the paper itself? Like if I write on the textbook itself? Do you guys have textbook?
Yes, sir.
Okay, then it's good. So rain is falling vertically. So what do I mean by vertically? If I take the basic directions as north, south, east, and west, rain is falling in the direction of north to south. Right? And wind starts blowing in the direction of east to west. And both these have magnitudes with direction. Okay. So though they use the word speed, here speed represents the magnitude of that velocity. Because vertically is taking care of the word direction. Correct, Ada? So rain is falling down with a speed of 35 meter per second. I still wrote 35 because this arrow mark that I drew is taking care of the direction. And this is going to be 12 meter per second. Okay. So if I take the same diagram and draw it, example 4.1. So rain is falling in this direction, 35 meter per second. And wind is in this direction, that is 12 meter per second. So there's velocity of rain, velocity of wind. Now, according to these two, right? So at this point, how will the resultant be? At this point, how will the resultant be? The resultant is going to be a diagonal passing through the common tail of these two because it forms a rectangle. They are rectangular components. So what law did I apply? According to the
parallelogram law of addition.
Parallelogram law of vectors, I can say this is going to be the resultant. So capital R here stands for resultant. Okay. So how much is the value? Root of, tell me what is the formula for parallelogram law of vectors? Root of a square
plus b square plus 2ab cos theta.
Yeah. What does cos theta mean? Cos theta is the angle between those two vectors. So root of a square is 35 square, b square is 12 square. So root of 35 square plus 12 square, whatever is the value, that is going to be the velocity of the rain. But the question is about what? They didn't ask what is the resultant of these two. Their question is very clear. So there is a boy standing with the umbrella in his hand. Okay. In which direction is the umbrella supposed to be held so that he doesn't get wet? So if you observe, since he is moving, since he is standing, it is because of the resultant of the wind and the direction of the rain that the resultant is going to be in this direction, making an angle alpha with the velocity of rain. Correct, Ada? So in which direction is he supposed to hold the umbrella? Is it not exactly in the direction in which the resultant is acting? Right. So this is the angle. I told you already, what does direction in physics mean? Direction in physics means angle. So they are asking in what angle is he supposed to hold the umbrella so that he doesn't get wet. Guys, observe, I'm going to solve the same thing using a different perspective. Can I write VR as a vector is equal to velocity of the rain vector plus velocity of the wind vector? What did I do here? I actually applied parallelogram law of vectors, but we know the fact that parallelogram law of vectors is the same as triangle law of addition. Do you guys remember all those things?
Yes, sir.
So,
Yes.
so VW is this also, because I told you if this is VW vector, this is also VW vector because they are parallel vectors. So VR vector plus VW vector will be equal to VR vector. This is from the parallelogram law of vectors. So what is VR vector? VR vector is equal to what is velocity of rain? 35 with a minus j cap plus velocity of wind is 12 minus I cap. Correct? So what will be the velocity of the resultant? Is it not square root of 35 square plus 12 square? So what I'm trying to say is, whether you apply parallelogram law of vectors or triangle law of addition of vectors, you're going to get the same answer. But if you apply triangle law of vectors, it is, especially for perpendicular vectors, it is easy for you to get the direction. Okay. So note down, if there is a vector like this, A vector is equal to A1 I cap plus B1 j cap. Okay, there is a vector only with 2 dimensions. Then tan alpha is given as B1 divided by A1, where alpha is angle made by resultant with x-axis. Guys, did you understand this logic?
Sir, I have a doubt.
Please tell me.
Sir, should the angle always be from positive x-axis or it can be from negative x-axis?
It can be in any direction. It can be in any ways. See, for example, A1 I cap plus B1 J cap, then let me say this is the vector A1 I cap plus B1 J cap. If this angle is alpha, then if I drop a perpendicular, this magnitude is A1, this magnitude is B1. You tell me what is tan alpha? Is it not B1 by A1? You can do the same thing with the negative x-axis also. When you take in terms of magnitude, you're going to get the answer. Okay, that is why whenever direction-based questions are asked, I'm very particular about one thing. What did I tell you guys? After you write the angle, you need to mention something. What did I say? Which most of them fail to do it. They write the angle as 37
With respect to which axis?
Yes, you need to mention. If you don't mention it, it is wrong. Because, see, for example, if there are two vectors perpendicular, let's say somebody has written the answer 37 degrees and leave. Maybe the answer sheet which I have will have 53 degrees, but both are right. You know what? Maybe the answer sheet that I had says 53 degrees with respect to y-axis, but you would have written 37 degrees with respect to x-axis. Both are right. But since you wrote only magnitude and left, there is a confusion that will get answered. Okay, then there is no point in arguing or something. So you need to be very clear whenever a question is based on direction, you need to mention it with the direction. Now I want you to take the idea from here and tell me what is the value of tan alpha. Okay, I will do one thing. I'll do a small change. I told you alpha is with respect to x-axis, correct? So I will take this as alpha. Now you tell me what is tan alpha.
35 upon 12.
That's so 35 upon 12. Very simple, okay? If you take this as the angle alpha, with respect to alpha, this is opposite and this is adjacent. You know that wherever alpha is there, that is adjacent. Right, tan is opposite divided by adjacent. So 35 divided by 12. So alpha will be tan inverse of 35 by 12. You need not write the answer. You can leave it as tan inverse 35 by 12.
Sir,
but
but
what
we
is
have to write with respect to x-axis.
Yes,
Right?
so that's what I was about to say. With respect to the direction of wind. Here you will not say with respect to x-axis. You will say with respect to the direction of wind.
Or ground also, sir.
Sir, can you tell me the definition of relative velocity?
There is no definition at all. The definition is velocity of one with respect to another. That's it. So relative means with respect to, that's it. So there is no definition at all. It is only the mathematical definition. So that is why you read it as velocity of 1 with respect to 2 is equal to velocity of 1 minus velocity of 2. That's all. That is a mathematical definition. But here in this question, I didn't apply relative velocity at all. Okay, in this question, I didn't apply relative velocity. I'll come to that. It is not needed in this question. Okay, I wanted to do the example. But am I clear with this point? Tan inverse of 35 by 12 with respect to the direction of wind, don't write it as ground. Okay.
So why not, sir?
Here it is not given, no? You don't know which is ground. What about this kind of a surface? Did they say that he's standing on a horizontal surface? Okay, you took it vertically like that. Okay, you can say it with respect to ground also. But I would suggest with respect to wind. Okay. That is more recommended. Is it clear? Concept wise, is it clear? Next. So this is a problem. Let's see. If you guys are able to just tell me.
Sir, tan alpha is equal to b1 by a1. This is applicable only if it is a rectangle, right?
If it is a 2-dimension, yes.
If it was a parallelogram, we can't.
You can't have it. If it is a parallelogram, then you have that formula. No, tan alpha is equal to
Yes,
b
sir.
sin theta divided by a plus b cos theta. Do you remember this?
Yes, sir. Yes, sir.
You have to apply it. Okay. Next. So find the magnitude and direction of the resultant of two vectors A and B in terms of their magnitudes and angle between them. This is already known, right? This is what is parallelogram law of vectors. Okay. So that is not a problem, it's a theorem. Let's look at example 4.3. There is a motorboat which is racing towards north at a speed of 25 km/h, and water current in that region is 10 km/h in the direction of east to south. Sorry, east of south, 60 degrees east of south. Find the resultant velocity of the boat. It's a good problem. Okay. So there are some important terms that I need to tell you guys here. So there is a motor boat which is racing in the north direction. So the velocity of the boat is how much? I'll draw a separate diagram here. So velocity of the boat is how much? 25 km/h. And the water current in that region is 10 km/h in the direction 60 degrees east of south. So what do you mean by 60 degrees east of south?
60 degrees southeast.
Southeast.
Don't use the word Ra. Okay, this I have to stress and tell you. If you use the word southeast, it's a hyphenated word. You cannot use 60 degrees southeast. No. If you use the word southeast itself, then there is only one possibility that it is 45 degrees. Okay. Whereas 60 degrees east of south means, am I clear? So when you use the word southeast, you should not mention the angle before it. No, that is wrong. Because if southeast comes itself, it means it is 45 degrees. Whereas if something like this is given east of south, south of east, okay, when something like that comes into picture, then whatever is the word after that of will be the starting point, and whatever is the word before the word of will be the ending point. Means this is south and this is east. From south, I need to turn towards east through an angle of how much value? 60 degrees. Are you guys able to understand this?
Yes, sir.
Right? So be careful with this. So this is there, this south. Okay. So south of east, sorry, east of south is 60 degrees. And there's a direction. So what are they asking? Find the resultant velocity of the boat. So there is a velocity of the river. River is ten kmph. Okay. So what will be the resultant, guys? How much is this angle?
120.
120. And this will be the direction of resultant. So VR is equal to how much is the formula? So VR is equal to root of VB square plus V small r square plus 2 into VB into VR cos of 120 degrees.
Sir, how can that be the resultant, sir? It's not a parallelogram, right?
It can be formed. Wait. So this is there, right? I can still form a parallelogram. Okay. So what does parallelogram law of vectors say? Can you revisit the statement and tell me? So what does the starting point say? If there are two vectors, this VB, this VR, if there are two vectors acting at a point, means if you have the condition of co-initial vectors, then you can always apply the concept of parallelogram law of vectors. Am I clear with this? This is one
Yes,
thing.
sir.
Good. So now you guys know how to calculate it, right? So root of VB square. VB is root of 25 square plus 10 square plus 2 into 25 into 10 into cos of 120. Cos 120, how much is it, guys? Trigonometry is over, right? Second exercise. Cos 120 is minus half. Okay, this and this will get cancelled with a minus sign left out here. Root of 25 square is 625 plus 10 square is 100 minus 250. So 625 minus 120, 150, whatever it is, take the square root of it, that will be the answer. So approximately 22 km per hour. Now what are they asking? Second point, find the resultant velocity of the boat. So they are concerned about direction also. So how to find the direction?
The formula which we told before.
What is it? Tan alpha. So which one you want to take? This one will be taken as alpha. So tan alpha will be equal to VB sine 120 divided by VB plus VR.
For 60. Okay.
VR plus VB cos 120. So what were you asking? 60?
The VB angle, it should be 60, right?
Why? See, this is the formula. This is these two are co-initial vectors. Okay, this is A vector, this is B vector. If I take this angle as theta, where theta is angle between A and B, then if I take this angle as alpha, then tan alpha will be equal to B times sine theta divided by A plus B cos theta. Here, the role of B is taken by VB. The role of A is taken by VR. Correct? The role of theta is taken by 120. So that is VB sine 120 divided by VR plus VB cos 120. Now is it clear?
So the whole angle is theta.
Yes, whole angle is theta. Theta is the angle between those two vectors. If you have forgotten, please go and revisit.
No,
Clear
sir,
now?
I thought you were telling angle between not VR and V2. I thought you were telling angle between VB and
VR
VR.
and VB and VR. Oh, this VR you thought, this one.
Yes, sir.
That is also not 60, no?
No, sir, the whole thing, VB and VR. Angle between VB and VR.
Angle between VB and VR, this is 120. This is 120. Angle between VR, the resultant, and small VR is alpha. That alpha is what you're going to find from this. Then you need to write the answer. Whatever you get, let's say tan inverse of, did anyone calculate it already? Tan inverse of whatever value you get, you should write the answer as tan inverse of that value with respect to the velocity of the river. Okay. Now I want you guys to try this problem. 2 minutes time, solve it and tell me. So rain is falling vertically with the speed of 35 meters per second. A woman rides a bicycle with the speed of 12 meters per second in the east to west direction. What is the direction in which she should hold her umbrella? What is the answer, please?
Sir, it is tan inverse 12 by 35.
12 by 35 with respect to
Wind, direction of wind.
with respect to the direction of wind. Now with respect to the direction of rain.
Rain.
Correct. Okay, that's right. Hmm. 4.12. Do this. Rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. What is the direction in which she should hold her umbrella?
Sir, what was the previous question's answer?
Sorry, what was the?
Never mind, sir. I got it, sir.
So rain is falling vertically with a speed of 30 meters per second. Okay. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. There is actually a tricky question. Let's see how many of you are able to solve. So unlike the previous question, this has some difference. Let me see. You guys try and tell me. See, did you all understand the question? The girl is, so till now, all the problems when we told rain was falling vertically, what did we do? We took the rain to be in the north to south direction and the girl was moving in the east to west direction, right? Whereas here, what is happening? The rain is falling vertically with a speed of 30 meters per second. A woman rides a bicycle with a speed of 10 meters per second in the north to south direction. Right? So how is it going to be? That is the question.
Sir, ZY plane.
So how we are supposed to do this is, see, generally, see, north pole, south pole, east, west. So north, south, east, west. You can either take it like this, or you can take it like this, in such a way that this side is north, the tip of my forefinger, right forefinger is north, and the bottom near the knuckle it is south. So this is north south, and the tip of my left finger as east and the knuckle as west. So north south east west. This is called as horizontal plane. Okay. So the girl is traveling from north to south in the horizontal plane, and the rain is falling vertically like this. So this is how they are. Are you guys able to visualize it? Right? So that is the trickiest part. Did you guys understand or not? Right?
Sir, can you repeat?
Technical ones.
See,
Sir, is it tan inverse of 3?
I don't know the answer. Tan inverse something 3. What are the values? Tell me. 30 and
30 and 10, sir.
then it should be tan inverse 3, but the direction is more important, right? That is where we face the problem. So this is north, south, east, west. That point you guys understood. No?
Yes, sir.
So if north, south is taken like the way I get my forefinger, and east, west is taken according to the left finger, then if you are able to draw a plane through it, then that plane is called as the vertical plane. Whereas sometimes what you can do is so east west is undisturbed, it is still in the horizontal. But if you take the north and south like this, then this is called as the horizontal plane. So if you're able to take a paper like this, then this is called as the horizontal plane. Okay. So the girl is traveling from north to south in the horizontal plane. That is on the road. If you imagine the road, no? If you imagine the road as a small rectangular paper, on the road itself, if I mark north, south, east, and west, where you're able to see everything, okay, then the girl is traveling from north to south direction like this on the road, and the rain is falling in the vertically downward direction. That vertically downward direction is neither north, south, nor east, west. Am I clear with that? So this is how the girl is traveling. This is how the rain is falling. So rain is in the vertical plane and the girl is traveling in the horizontal plane. So how will the resultant of these two be? It will be somewhat like this. Right? So what is the speed with which the rain is falling? 30 meters per second. What is the speed with which the girl is traveling? It is 10 meters per second. So if I take this angle as alpha, if this is the resultant, and if I take this angle as alpha, which I will draw it on the paper, if I take this as north south, then if I take this angle as alpha, velocity of rain is 30, velocity of girl is 10, then what will be tan alpha equal to? So what you told is right, 3. So but alpha is equal to tan inverse of 3 with respect to whom?
Sir, in the diagram which I drew, it's with respect to z-axis.
Okay, you took z-axis. Okay, with respect to girl. Okay, it is with respect to girl.
Yes, sir. Same, sir, with respect to girl.
Yes. So I hope everyone is clear, right?
Yes, sir.
Yes.
Sir, in
Can I
the
rub this?
previous question, sir, in the
Please tell me.
previous question, if the answer is tan inverse 35 by 12, then it is with respect to what, sir? Girl.
With respect to rain. There it was like this, yeah? It was 35 this side, 12 this side. So if this is taken as alpha, you wrote tan inverse of 35 by 12 with respect to girl.
Yes, sir.
So then this is the girl, this is rain. So tan inverse of 35 by 12 with respect to girl, or tan inverse of 12 by 35 with respect to rain. Both are correct.
Okay, sir.
Both are correct. Okay. About the relative velocity concept. There is one more problem. Okay, you don't have this theory, but I will explain it. You have to look at it like a problem. So, based on relative velocity, there are different kinds of problems. One is called as wind rain problems. Sometimes you will have air and a cyclist or a flight problem. Okay. So something like that will occur, but those things are not there in your syllabus. So you need not worry. Out of which one of the problems is a man and a river problem. Okay. Means what will be there is there will be a river and a man will try to swim in that river. That is this problem. Okay. So read the question. What are they trying to say? There is a river and a man can swim with the speed of 4 km per hour in still water. How long does it take to cross a river 1 kilometer wide? How long does it take to cross a river which is 1 kilometer wide? If the river flows steadily at a rate of 3 km per hour and he makes his strokes normal to the river current. How far does the river, how far down the river does he go when he reaches the other bank? Oh, I have certain questions to ask before I do this problem. So let me teach the concept. Man and river problem. Okay. So generally, if you take a river, this is the width. So generally, the width of the river will be given. Let's say the width of the river is D. And let's say there is a man who's starting at this point. So when he's and let's say this is the direction of the river, means the river is flowing in this direction. See what you would have observed this, right? Let's say there is a rainwater that is there on the road. So the rainwater can either be stagnant, that is, it can be stationary, or sometimes the rainwater will flow down the slope. Right. Suppose you imagine and tell me the answer for this. Suppose there is a small road like this where there is some rainwater. Okay. So in this portion, is the rainwater going to be stationary or is it going to move? Logically, it has to move. Right. Let's say I give you a paper and you make a paper boat and keep it on top of this water. Will that boat be able to be at rest? What will happen to that boat?
It will move with respect to ground.
It will move with respect to ground. It is going to have motion. But the question is, you kept it at rest only. You didn't give any velocity. But where does it get the velocity from? Who is actually making it move? Is it not this water current? I call it as water current because current generally means something which is in motion. And here the water particles are in motion, so I call it as water current. So it is a water current that is carrying away the boat, the paper boat which you made. Right. In a similar way, if I have river, then the river can have either water which is stationary when it is not disturbed, or it can have a current. Means the water itself can have some velocity. Let's say the water is flowing in this direction with a speed of VR. Where this VR is what I call it as velocity of the river water with respect to ground. Means I'm talking about the absolute velocity of the water. Am I clear, guys? Am I clear? Right. So here, if you read the question, there is a man who can swim with a speed of 4 kilometers per hour in still water. Velocity of the man. See, this is where many people do mistake. Just because they see the word still water, they think it is the absolute velocity of the man. No. Okay, listen. If I call Vm as the velocity of man, then Vm with respect to r is called as velocity of man with respect to river or still water. Okay, means this will be the velocity of the man when observed from the ground frame of reference. This will be the velocity of the man when observed from the still water frame of reference. Still water means water is at rest only. Okay, so VMR stands for the velocity of man with respect to river, or with respect to still water. Okay, so these are the two important words I wanted to stress upon. Please make a note of this point. So this is the grammar of physics for a man and a river problem. So whenever you read a question, these are all the terms you need to make a note of. It is then you can solve the problem. Trust me, the problem solution is only 2 steps. But 90% of the...
Sir,
Please tell me.
sir, then what is the difference between velocity of man and velocity of man with respect to...
Velocity of man is absolute velocity of the man. That is when you observe from the ground frame of reference. I told you, right? Velocity of man is velocity of man with respect to ground. We don't write g every time. I told you in the previous chapter.
Yes, sir. Sir, but the water is still, right?
That is a naming structure. That is what I'm trying to say. That is a naming structure given in this context. That is what I'm trying to stress upon. Make a note of it. That is how they have named it. The reason I'm telling you is because if you observe in this question also, they're using velocity with which a man can swim is 4 kilometers per hour in still water. That is the velocity of man with respect to river. That is what they're trying to tell you. Generally, if I give you this question without explaining context, what would you do? Because you will see the word still water and you will write velocity of man, absolute velocity of man is 4. No, you'll never get the answer. Because in this context, okay, whosoever has defined it, I don't see, actually I didn't do it. Universally, this is what is followed. Wherever they say velocity of man with respect to still water, so this man alone is solved from 2 frames of reference. What is it? One is with respect to ground. When you take the reference as the ground, then it is absolute velocity. Whereas when you take the reference as still water, that will become the velocity of man with respect to river. So in this context, 4 is what? VMR or VMG?
VMR.
That is the meaning. Okay. So yeah, tell me.
So once, could you scroll up till for 4.1? We solved the example, right? 4.1.
Yeah, 4.1 is based on parallelogram law.
Yes, sir. Once if you have it out. The one which you solved, sir.
Yeah.
Yes, sir. Here we wrote tan theta is equal to 35 by 12, right?
No, I wrote 12 by 35. No? I didn't write anything. Did I write?
So you wrote 35 by 12 with respect to wind.
Yeah, I took this as alpha. I wrote tan inverse of 32 by 12 with respect to alpha.
Okay, sir. Alpha. Okay, sir. Got it.
Got it? Yeah.
Yes.
Okay. Guys, now I'm going to tell you an important point. Listen to this carefully. Okay, man. This is velocity of river. Okay. Now, have the paperboard thing in your mind and think. There are two types of questions that they can ask. The first type of question is, how should the man start moving so that he reaches the opposite side in the shortest time possible? Did you understand this? How should this man start swimming? So the man is exactly actually starting in the direction from one of the ends, one of the banks of the river. But the river is flowing in this direction. Okay. So how is the man supposed to start moving for him to reach in the shortest time possible? Second is, how should the man swim so that he covers it in the shortest distance possible? Okay, shortest time, and the second is shortest distance. Okay. So when he wants to move in the shortest time, he will start moving exactly perpendicular. So if he has to reach the other end in the shortest time possible, then he will start moving with a speed of v, velocity of man with respect to river, exactly perpendicular to the flow of water, or exactly perpendicular to the bank. So what will happen to this man? So let's draw a free body diagram and see. Free body means a separate diagram. This is VMR and this is VR. Then this is going to be the resultant. Guys, am I clear with this point? So what law are we going to apply here? It is parallelogram law, because I have co-initial vector. Is there anyone having doubt with this diagram? See, it's a tricky part. Please concentrate. If there is any doubt, get it clarified. Is there any doubt?
Sir, I have a doubt.
Please tell.
Sir, if the man like moves from the river, like one bank at an angle greater than 90 degree from the velocity of river, then
Okay.
is he going to cover more distance than when he when he left at 90 degree with the river?
When he's moving at 90 degrees, he's not going to cover less distance, but he's going to take less time. Okay, here my context is with respect to time only. Can you tell me why will he take lesser time? It is because the water current will help him to flow. See, had the water been still, if VR was 0, then he was supposed to move with that velocity only. He is supposed to put in all the energy so that he reaches the opposite end. But now what is happening? He started moving exactly in perpendicular direction and the water keeps pushing him slightly so that he will get drifted. Let's see what is going to happen. But here, if you observe an important point, I would have written the velocity with which the man is moving with respect to river is VMR. That is, he starts exactly perpendicular to the surface. Okay, and this is the velocity of the river. R, small r stands for river. Am I clear? So capital R stands for the resultant. Now, if I apply the parallelogram law of vectors or the triangle law of vectors, can I write VR vector is equal to velocity of man with respect to river vector plus the velocity of river vector? Guys, any doubt in this step? That is, the resultant is equal to sum of the other two sides in terms of vector. So velocity of man with respect to river is velocity of man minus velocity of river. That is a basic definition of relative velocity. Plus you have VR vector. So this and this will get cancelled and this will be BM vector. Means the resultant that is occurring is the exact velocity with which the man is moving. Means this will be the exact velocity of man. Sorry. And what will happen is he will neither be able to reach the opposite end. So he will not be able to reach the opposite end and he will get drifted slightly and this is the place, means he will get drifted by this distance due to the water current, and he will reach a point P in the shortest time possible. Okay. Is it clear till this step? Did you guys make a note of it? Yes or no, guys?
So just a minute.
Sorry, I didn't get you. You're noting it, no?
Yes, sir, just a minute.
Yeah, please.
Yes, sir.
Now I want you guys to try this one.
Sir, the time is up, sir.
Just a minute, that will do it. Just 1 minute and we can finish it off. So this part alone we will write. So velocity of man with respect to river is 4 km/h. How long does he take to cross the river, which is 1 km wide, if the river flows steadily at a state of 3 km/h and he makes strokes normal to the river? Okay. So how long does he take? You guys tell me. So this is the direction of velocity of man with respect to river. Correct, Ada? This is 4. And how much is the distance he is traveling in the vertical direction?
1
It is
kilometer.
1. So what is going to be the time? Time is equal to distance by speed. What is the distance? 1000 divided by speed is 4. Cancel it. It will be 250. Actually, it is 4 km/h. You can make it 60. So, sorry, 1 minute. I don't know why I wrote 1000. So you can write it as 1 divided by 4. He will take 0.25 hours. 0.25 hours is how many minutes? He takes 15 minutes to cross the river. How far does the river carry him on the other bank? So if he is reaching here, who's responsible for it? Please tell me.
Sir, could you repeat how it's?
No, time is equal to distance by speed. So what is this vertical distance between the 2 points? It is 1. And what is the speed with which he is moving in the perpendicular direction? It is 4. So you are asking how we got 50, no?
No, sir. No, sir. Understood, sir.
Understood, right? Huh? So this is about 15 minutes. He takes 15 minutes to cross the river. How far down the river does he go when he reaches the other bank? So what is the distance between AB is what they are asking. So AB is equal to distance into time. Sorry, speed into time. AB is equal to speed into time. Which speed is making him move in the horizontal direction? It is the speed of the river. So 3 into this 15. So he moves by a distance of, the 3 is in kilometer, right? So 3 into 1 by 4, he moves by a distance of 0.75 kilometer in the horizontal direction. That is 3/4 of a kilometer. That's it.
Sir, could you repeat the second part?
See, this is the question. Did you understand the question? How far down the river does he go when he reaches the other bank? When he reaches the other bank,
Yes, sir.
it is because of this 3 km/h, he is able to get drifted by this value. And he is getting drifted in this direction for a time of how much duration? For 15 minutes or 1/4 of an hour. So 3 km/h into 1/4 of an hour will give you 0.75 hours. Sorry, 0.2.
Yes, sir. Understood, sir.
That's it, guys. So if there is no doubt, we can wind up. I think your Max sir has joined. There is no doubt we can wind up, guys. Okay. So I'll see you all tomorrow.